Uh, Hello everyone. I hope everyone is safe and staying inside. So my name is Manank Patni, and today we are gonna have a webinar on API programming with blockchain. So in this webinar, I'm gonna show you how to integrate your apps with XinFin XDC network. And if anyone wants a certificate, we have them available. All you have to do is give a short test. Don't worry, it's not going to be so hard. You can get the link for the MCQs down in the description. So yeah, let's begin. So uh, to get everyone accompanied with the basics of blockchain, let me tell you what exactly blockchain is, so that anyone who doesn't know anything about blockchain doesn't feel left behind during the entire webinar. So a blockchain is basically a digital ledger. So a ledger is a record of financial transactions in accounting terms, but here it is in the form of data. So a blockchain is basically uh, a, a, a ledger of data where this ledger is distributed and duplicated across different computers all across the globe. So whenever a database is decentralized and is managed by different participants, such a technology is known as distributed ledger technology. So blockchain is a subpart of distributed ledger technology. A ledger is distributed whenever its copies are replicated across different geographic locations. So there is no single copy, no single organization have the access to the database. They don't have any read or write access. Everything is consensual based and managed by peer-to-peer protocols. So we use different cryptographic mechanisms to make it secure and um, make it work. So a blockchain is one of the types of distributed the technology. Blockchain uses blocks and form chains using those blocks to keep the data and keep the shared state. So what exactly are blocks and how this chain is formed? So a block basically it essentially contains a list of all the transactions a particular a particular uh, from a particular time period. So what makes this a chain is every block has a hash of the previous block, whereas it has its current hash along with the transactions. So as you can see, the block number 186 has the hash of block number 185 in it. So that means that a chain is formed which cannot be broken down until and unless everyone participating in the blockchain agrees to it. So to add a new block, they have to the different peers have to agree. So how a blockchain works? So each blockchain contains a number of transactions, and these transactions are stored in form of block. So whenever a person has to make a new transaction, all they have to do is send that transaction behind the scenes. That transaction a lot of transactions are merged into a block, and then that block is broadcasted to all over the network. So basically the network means all the different computers that have this copy of ledger that I told previously. So the network approves the transaction uh, by using different consensus mechanisms that I'm gonna teach later. And
Hi
the
Manang.
block.
Manang, your slides. The slides are not changing. It's still on the first page.
Okay, is it okay now?
Yeah, it's perfect.
Okay, so sorry guys for that. uh, So if you missed anything, I'll share the presentation later on. So um, so once a block is added to existing blockchain, then the transaction is completed. So there are different type of blockchains. One is public. There are permissioned or consortium-based blockchains, and the third one is private. So a public blockchain is where anyone can participate, anyone can enter, and they can do any kind of transactions. There is uh, no restrictions and no censorship. So examples would be Bitcoin or Ethereum, whereas or consortium blockchains are something where participants are all known, and they are given certain permissions, they are given certain rights, and they can only do those certain things on the blockchain. Whereas a private blockchain is one we use for our testing as a developer, and then they're basically not used in production. So there are different consensus algorithms. Since I told you that no single organization or uh, person has access to the data, and they do not have any right over it. So this has to be done by the network, and to do that there are different algorithms like proof of work. There is one proof of stake, and there is other one delegated proof of stake. So the proof of work algorithm requires the computers to solve a very, I can say, uh, difficult, uh, complex formula, or you can say a puzzle. Uh, so once that whoever solves that puzzle first uh, gets a reward for solving it, as well as that block is entered into the blockchain. So the person who does these things is called a miner, and the miner is basically responsible for for adding new blocks into the blockchain. Uh, but the cons of proof of work is it's really time taking, and it is not scalable, since these cryptographic puzzles are really hard to solve, and they require a lot of time and energy. So Bitcoin and Ethereum currently use them. That's why they take a lot of time to to finalize their transactions. So the next algorithm is proof of stake. A proof of stake algorithm uh, basically has the participants, they have a stake on the blockchain. So the number of coins they have, or the number of um the stake they have on the chain, just like shares on companies, they hold that much voting power. So whoever has more voting power is allowed to put that the block of their choice into the chain. So proof of stake is really fast, and it does not have all the problems which proof of work has, but it still has its own problems. So then comes the delegated proof of stake. So the blockchain network that we are going to um, uh, look more into today is XinFin XDC network. So the XinFin network uses algorithm called delegated proof of stake. Here, a group of representatives who are allowed to merge a block into the chain are selected by um, all of the peers in the network. So it's basically like the government works. For example, we choose our representatives, and then they go to the assembly, and they run the country. So that's how a delegated proof of stake in a nutshell works. So the peers choose a group of representatives, and then they merge the blocks into the blockchain. So a very essential part of blockchain are smart contracts. So smart contracts are nothing but logics which are placed on blockchain. So a computer code that is not on blockchain can be manipulated by anyone who basically has the right of the server or wherever the code is present. But once it is on blockchain, uh, no one has no one has the access on it, and the rules which are predefined, only it works only on those rules. So there are different features of smart contracts, like it is trustless, no single party has access on them, and uh, they cannot be tampered with or they cannot be changed. Smart contracts are trackable since blockchain is a ledger and all of the transactions are present on the chain with anyone, so we can track what happened throughout the history, and they are irreversible. Once it is done, um, it is done. So no one can once do something and revert it back, which is very easy to do in a centralized uh, or a web 2 based application. So applications that are made using smart contracts or on blockchain are called dApps or decentralized apps. So these are self-executing. They reduce a lot of cost, and they increase the speed of overall working of the of the code. So today we are going to look into XinFin blockchain. So XinFin network is a public EVM compatible blockchain. So whatever you can do with Ethereum, you can easily do it with XinFin. The only thing is it is really fast and it has really low gas cost. So XinFin has a low transaction fee, whereas you can see the average fee for any Ethereum based transaction is like 0.13 USD, or it goes to even more than that, and it has very fast confirmation time. Whereas Ethereum and blockchain have like they are really not scalable, and it takes a lot of time for transactions to get merged. And XinFin used DPoS consensus algorithm, as we learned previously. So XinFin has a lot of great tools available to help developers. These are XinFin Remix, where you can create smart contracts using a very beautiful and easy to use GUI. We have a XinFin Chrome extension, and we have XinFin Explorer, where you can check through all of the transactions and uh, the the details of those transactions. Whereas the documentation and support is really good. So uh, this is the step these are the steps to create an application on blockchain. So first of all, we need to create a wallet or an account on blockchain. So enough of the theory, let's dive into the code now. Yeah, so first of all, we'll create an account. So XinFin has a really cool library named XDC3. um, this can be used to connect to the chain and perform various transactions so all you have to do is include this library into your existing code. Um one, Once we have included it, we have to create a new web3 object, and we have to connect it to a HTTP provider. This is the link to uh, XinFin's testnet. So there are different type of chains. For example, there is a mainnet and there is a testnet. So mainnet allows the real world transactions, whereas testnet is supposed to be for development purposes only. The tokens do not have any value, uh, and basically you don't have to spend your real money to do any kind of transactions. So so this is a small function called web3.eth.accounts.create. Here we give some entropy. Entropy is nothing, it can be any random string, uh, and it is going to create a new account for us, uh, and give its private key. So there are three ways to create wallets on Ethereum or any other blockchain like XinFin. These are, you can create a wallet account as well as get its private key, whereas the other one is you can get create a wallet and get the account and all its details like private key and public key in a file named as key store. So a key store is secured by its key store is
I
secured
will
by a
ask,
password.
your screen is not visible, so you can just stop sharing your screen, and then you have to share your entire desktop. Audience is just able to see your presentation. So you
uh,
have to share your entire desktop.
बंद करो. I hope it is visible now.
Yes, man, perfect. Yes.
Okay, sorry again for that. Uh, so as I was telling, this is the library used by which we can use to interact with the XinFin blockchain. So as you can see, all I have to do is include it and create a object for Web3, and inside this object I have to pass a HTTP provider. A HTTP provider is is the link to the network itself. So uh, this was the function I was talking about earlier. It's web3 at the accounts dot create, and I have to pass in a random string, which is going to increase the security of our private key. So let's create this account, and all you have to do is run this, and here we go. We have an account as well as a private key. So
Can you
the
try
private,
zooming in, Manank? Some more,
is it okay?
some more should be perfect. Great. Yeah, that works.
Okay.
Same size for the code as well. Great, amazing.
Yeah. So this is the private key, and private key is supposed to be, um, as you can read, private. So you don't have to share it with anyone, and whoever has the private key can manage your account and do all kind of uh, things that you would do. So this is your address, and this will be public, and this is how everyone in the blockchain would know you. So let's create two accounts here. Yeah, so uh, we have two accounts now, and let's just save them so that we can use later. Yeah, so now that we have two different accounts, let's go to the XinFin faucet and get some test XDC. So this faucet will give you 1,000 XDC or tokens to pay the gas or to do different transactions on chain. So gas is it's like the tax, or you can say the fees you have to give to the network to perform different transactions on it. So it's successfully transferred to our account, and you can see it has given us a transaction hash. So this is the XinFin Explorer. So you can see the balances of all the accounts. You can see the transaction details and lots of informational things on this Explorer. So let's wait for a moment for the transaction details to come. Okay, let's refresh it. It is taking some time. While you can see the different, you can see the details of transactions on the Explorer. You can also use the XinFin API, which is a really great tool to get all these details using code. So let's use the get transaction by hash endpoint to get the transaction details. So this is called the hash of transactions. Let's just copy it and store it somewhere. So since this is an API, you can basically use any API calling module that you'd like. For example, I am using Axios in today's webinar. So you have to uh, import the whatever library you need, and after that you can just go to the API documentation, and you can see all of the code is available here. So you can just basically copy paste it and make it work. But for showing how it is done, I'm going to do it myself. So this is the data that we need to send uh, to our to the chain, to the API. So I'm just gonna copy paste it and change the transaction hash. So our hash is this, and we need to send this API request to xinfin.network slash get transaction by hash. So as I told you, there are two different type of networks. One is mainnet and one is testnet. rpc.xinfin.network is livenet. So whenever you want to do some real world transactions or send some real XDCs, you need to use this endpoint. Otherwise, we'll use the testnet for now. So the files, all I'm doing is now sending a post request to this URL, and yeah, getting the data back. So file's name is get transaction by hash, and once we run it, here we go. So these are the transaction details. So this is exactly what we are going to get in the Explorer, but this way we can get it from the code. And all of this data is in hex format, so you can change it to integer if you'd like. So let's say we want to see the value. So the value is the amount of XDCs that were transferred to us. So that would be in result dot value. So dot result dot value. So this is in hex, so we need to convert it to integer. So I'm going to pass it to int. So yeah, you can see it is 1 raised to the power 21. So as you, some of you might know that a blockchain's values, uh, token values is determined by decimal point, that is usually 18. So we need to divide it XDCs by 18, 10 raised to power 18. So yeah, this is the real value of XDCs that we are getting. So this is 1000 XDC as we saw in the faucet. So now our account 1 has 1000 XDCs in it. So let's try and execute a transaction which is going to transfer uh, a few XDCs to our first account, from our first account to our second account. So to do that, you need to create a transaction. So there are different ways to create a transaction. I am currently using the Web3 library itself to sign a transaction first and then send it to the chain. So I have, let's copy paste the addresses, and since we are transferring from account 1, so we need its private key also. Otherwise we do not have any access over it, any permissions. So yeah, we got the accounts, and oh, this is the wrong file, sorry. We need to send a transaction, a simple transaction. So some of you must be known to the Ethereum chain, and as you can see, these functions are somewhat familiar to you. So uh, I would like to tell you that XinFin network is completely compatible with Ethereum based tools. So all you have to do is import XDC instead of Web3 and change the HTTP provider for any of the Ethereum based URLs to the XinFin's URL. Yeah, this is done, and yeah, now this is done. Now uh, first of all, we need to sign this transaction using our account's private key. So signing a transaction is basically giving permission to execute this transaction on on the account owner's behalf, and with these certain values. So let me explain to you what this value mean. Nonce is the number of transactions this account has had. So if this is the first transaction for this account, then the nonce will be 1, otherwise it will be 2, and it will go on like that. I need to send the XDC from account 1 to account 2. So from a 2 means the addresses of account, or it can be address of a contract. We're going to see that later. So value would be the number of XDCs we need to send. So to send one XDC, we need to essentially write 1 and 18 zeros. So this is how we have to pass these values in XinFin or Ethereum. The gas, as I told you, is the tax or the fee we are paying to use the network. So we are giving 3100 gas, and the price for that gas would be 2500. Uh, you don't need to worry about it a lot in this phase since we are just using testnet, but this will be an important factor to see when we are doing it on mainnet. So Let's keep that into your mind when you are using mainnet. So uh, once this transaction is signed, we are going to push this transaction using send raw transaction endpoint of the end of the XinFin network. So I'm gonna just show you what a signed transaction looks like. Nodes and transaction.js. Yeah, so this is a signed transaction, and this is a raw transaction that we need to send uh, in our transaction. So this is a hash of all the details or everything that we wrote here, along with the permission. So yeah, so we need the raw transaction field from our JSON. So we are say, um, we will be sending the data, which will have its parameters as rest.raw transaction. Um, all of the data and the endpoints are available on the documentation. So you can see what data is required and in what format from the documentation itself. So here it is. This is the send raw transaction method, and you can see I just copy pasted the data. This is what we can say, a really cool thing for good documentations is that you can just copy paste a lot of things, and you don't have to like worry about how certain things are gonna be. So I just changed one thing, that is change the params to rest.raw transaction, which is we are getting dynamically, and we need to then post it to rpc.zinfin.network/and raw transaction, and that is exactly what I'm doing here. So now let's send this transaction to the chain, and here we go. Oh, we don't have sufficient gas price. That is because, let's see what happened here. Uh, we copy pasted our this is strange. Let's try it once again. This is the thing with coding, you always run into some errors, and so the error which is occurring here is insufficient funds for gas price plus value. So let me check once again if the value is correct. Let's send a little less value here, and no, it's again wrong. So this means our account does not have uh, any funds in it. So let's go to the Explorer and check if we really have any funds or not. And we paste it here. Let's try to get some from the faucet again. Maybe I copy pasted the wrong address before. Can happen. Let's try it once again. Yeah, so that was the error. We did not have enough XDCs in our account to send them, and uh, once we got them from the faucet, the transaction was successful. So let's see this transaction again. This time we are going. We'll also will use our uh, get transaction by hash file again. So I just pasted it here and let's run it again. Get transaction by hash, and it is 1 e raised to the power 10 to the power 18. So it is really less. So it basically says that the value is was really less because uh, it was there, but it was really less. So since we sent only 10,000, which if you divide by 10 raised to the power 18 is 10 raised to the power 14. That's why this error is coming this way. So let's again. So I'm just doing it manually, but this is not the way it is done. We use a library called bignumber.js, and we handle these large amount of values using that library. So let's do another transaction, and this time it's gonna, oops, yeah, and this time it's gonna show 1. So 10 raised to power 18 XDC means 1 XDC. So this is correct, and you can see it was really low amount. So now let's see our address on Explorer. So you can see the overview of our address here. It now has 998.9999 instead of 1000 which it previously had. So these are the transactions that occurred during this time. First we got 1000 from the faucet, then we transferred this amount, and then we transferred 1 XGC. So this is a really simple way to integrate crypto into your app. All you had to do was to um, sign a transaction and then send that raw transaction to the XinFin network. So uh, this was a very basic transaction where we just transferred some funds from account A to account B. So now let's go to some more complex things like writing a smart contract. So a smart contract for XinFin is written in Solidity. Solidity is a widely accepted language for writing smart contracts on blockchains. So as you can see, this is a very basic contract. All I have is one variable named x and two functions, one to set the value of x and the other one is to get the value of x. Uh, this is the way we declare a function in Solidity. We use different terms to define the different type of access or visibility they have. For example, both of these functions are public, but one of them is a view function. So a view function means that we can only see the values. We cannot change any value. Here you see I took a value into the parameter and set the value of x to a new one. Here all I did was return a value of x. So uh, this is not changing the state, whereas this is changing the state. So that's why it is view and this one is not. There are other ones also, but these are the most basic ones and most widely used. So to to interact with the contract, we need to compile it and then deploy it on our chain. So first of all, let us compile it. To compile the contract, there's a module called SOLC. So SOLC stands for Solidity Compiler, and a Solidity Compiler compiles the smart contracts, and then we need two things from the compiled contract. First of all, we need the bytecode, and the second one we need the ABI. So a bytecode, a lot of you would be familiar, is a machine readable format for code which a virtual machine can execute. So XinFin is EVM compatible. EVM stands for Ethereum Virtual Machine. So the bytecode is executed on the Ethereum Virtual Machine, and the second one is ABI. ABI is ABI is a JSON-based specification for how our contract is going to look, what will be the different functions, what would be the parameters the functions would take, and what different things it would return. So let's compile this contract and see what ABI and bytecode we get. So node compile contract.js. And it will take some time to compile it, and here it is. So this is the bytecode and this is the ABI. So as you can see, the ABI has the names of functions that we wrote. For example, there is set and there is get. Yeah, here is get. So we now our Ethereum our Ethereum virtual machine would execute this, but our our, um our module, our XD3 module would know that these are the functions by seeing our ABI. So let's first of all deploy a contract. So you can see all of these things are same. One thing I forgot to tell you last time was nonce. So the nonce is the number of transactions account has. So to get a nonce, we need to pass nonce to sign a transaction. So this is a function we use to get the nonce of an account. So all you have to do is pass in the account address, and you can get the nonce. Now we'll copy the bytecode to the bytecode variable, and ABI to the ABI variable. So we use the Web3 object which we created here to create a contract object. So a contract object will be created by passing in the contract's ABI into it. So we need to pass it in JSON format. So that's why I'm passing it to JSON. And once this is done, we can interact with this contract. So first of all, we need to deploy it. If it's already deployed, you can also pass in the address here, which we are going to use in the next one. So we pass in the bytecode to deploy, and then we call this function called encode ABI. What encode ABI does, it it uh, it changes the format of our function, or the thing we need to call into Ethereum virtual machine known format, and then we send it in a data field. So the data field will contain if we need to execute a function, or if we can uh, deploy a function, or we can simply just send any arbitrary string or value in it. So again, we are signing this using the sign transaction function, and once we get the raw transaction, we're going to push it using the post like we did earlier to send raw transaction, and the contract will get deployed. So let's do this. First we need to copy paste our new addresses, otherwise it is I'm going to use the old addresses, and the third address. Yeah, perfect. So now we deploy the contract. This is the raw transaction, and here it is. The transaction has been done and our contract is deployed. So let's see this transaction. So here it is. This we can see it came from this account, and we created a contract which is situated, which is present on this address. So contract account addresses also have the same address as that of an account. So here the value is 0 because we didn't send any value, and the nonce is 2 because this is the second transaction we made. Nice. So now what we can do is we can execute different functions of our contract. So we have two functions, we have set and get. So first, if we get the value, it's going to be 0 since uh, x is defaulted to 0. So let's execute a transaction function. Oh, we already changed this. Okay. Yeah. So again, we are going to pass in the ABI. We're going to pass in the nonce and the A, the ABI along with this time the address. So as I told you that if you need to uh, use a previously deployed contract, you need its address. So we can get it from our explorer, and let's just copy this and paste this in our contract address variable. So first we are going to uh, call the get method. So once we have the contract object, we use contract dot methods. The methods will contain all the methods the contract have. Like in our case, it's set and get. So we'll call get and this call function. This call function is what calls the function. So you can see this function is a view function, so it's not going to change any values. So that's why we do not need to run any kind of signing transaction thing in this. We can directly run this. Then we are executing the set method. So I'm again using contract.method.set and setting in a value, let's say 678 instead of whatever. So again we are using the encode ABI, which is going to encode our parameters as well as function signature. Uh, and now since this function is going to change the state, we need to sign it again so that it knows from which account this transaction originated. In data, we pass in the encoded function, and once it is signed, we again send the raw transaction to the send raw transaction endpoint, and we're going to check if the values changed or not after a transaction has been done. So let's execute the transaction method. Okay. Mm, Okay. Return values are not valid, they return out of gas. So this is an error that came when we were uh, running these transactions. Let's see. Out of gas error can come when you have given very less gas, or maybe the transaction was not correct. So let's debug this. First of all, we are going to check what the value for our x is without setting it. Oops, return values are not valid. Let's see. We passed in the correct ABI. We passed in the correct address. And let's change the ABI again. And the contract address. Okay, this is the address of the contract. Hmm. Okay, there is some error with something that we are doing. Hmm. Okay, let's check what we are doing wrong. So let's say instead of getting the value, we directly set it once. Uh, yeah. Oh, it again failed. Maybe we didn't pass the right. Okay, so this is strange. Let's deploy the contract again. Let's see if we made some error while deploying it. So this is the deployed contract bytecode and ABI, and we're passing the ABI correctly, the bytecode correctly, and the private keys are correct. Okay, so let's deploy it again. Yeah. So this is the transaction. Let's see it once again. Let's get our transaction receipt. So this is a file from where we can get the transaction receipt. So all we have to do is pass in the transaction hash and we can get the receipt. So that transaction file. So transaction receipt and transaction hash, these are two different uh, endpoints. So yeah, this is our contract, and Node execute transaction method or just. Hmm, strange. It ran out of gas. Let's try giving it a bit more gas. It's still failing. Yeah, so uh, let's give it a minute, and if it doesn't work, then we'll leave it. But this is exactly how this is done. There must be some error in the maybe the private key or maybe the account, but I can assure you like this is how it works, and you can try it when you try it on your own. This is going to work. Okay. Uh, yeah, so unfortunately, I'm not able to make it work right now. I don't know what exactly the error is because I've been trying this. Uh, I tried this like 3 to 4 times and it was working. And these kind of things happen when you change even a bit of code, then you are like prone to go run into some errors. But yeah, it's fine. It happens. Yeah. So um, just wanted to tell you more about what XinFin is. They have a great APIs uh, which you can go and visit at api.xinfin.networks. You can get the balance, you can get transaction count, you can send transactions, and you can estimate the gas cost for a transaction. And as we saw, you can get the transaction hash and transaction reset. Uh, all of these functions are completely uh, provided on the documentation. All you have to do is just copy paste and change the parameters a little bit to make it work according to your application, and this is going to be really easy for you to integrate your existing application, or if you want to create a new application with the XinFin has great documentation. You can go to XinFin howto.xinfin.org, and the mainnet and the test nets always test on test net, otherwise you're going to lose real money. And XinFin Remix is a great tool which you can use to and test and write your smart contracts. It is really easy to use, uh, and and really interactive. So you can directly deploy a contract from here, and you can compile it, you can check for the errors and all kind of stuff. XinFin also has a Slack. Just go to the Slack channel and ask for any doubts or queries you have. Uh, Also, if you have any questions from me, I'm available on LinkedIn as well as on Telegram. So you can ping me anytime. I'll be happy to solve any of your questions. So, yeah, this was the webinar, and sorry for all the troubles in the beginning where you were not able to see the code and the presentation. And I hope you found it useful. Thank you. Okay. Again, if you guys want the certificate for this webinar, you can go to the description in the video and get it from there. It's a easy 25 MCQ test, and it's not really hard, so you can easily pass it. Hi Yogesh.